Hello students, welcome to the class. So let us continue with the system of particles and rotational motion chapter. In the last class we discussed about the different types of motion like translatory motion, rotational motion, and the terms related with translational and rotational motion. There's a definition like angular velocity, angular momentum, right? Those all the points we have discussed. And after that, the expression for those physical quantity also we discussed, and we saw the main difference between the rotational and the translation motion expressions, right? So now let us see the next point, that is rolling without slipping. In case of combined translatory and rotational motion, if the object rolls across a surface in such a way there is no relative motion of object and the surface at the point of contact, the motion is called as what? Rolling without slipping. This the motion is called as what? Rolling without slipping, right? Then the friction is responsible for this type of motion, but the work done on the dissipation of energy or the loss of energy against the friction is zero. Okay, so here the friction is responsible for the rolling of a body, but here what happens? The loss of energy is zero due to the friction because of the relative motion between the body and the surface at the point of contact. So in the figure you can see that the rolling motion of a body may be treated as a pure rotation about an axis through point of contact with the same angular velocity omega. By the law of conservation of energy, this can be written as kinetic energy is equal to half mv square, and for rotational motion it is given by half I omega square, where v is equal to r into omega. Substitute the value of v, that is given by m r square omega square plus half I omega square. We can take omega square common, therefore we will get it as m r square plus I. Then next we can also write it as half omega square into bracket I m r square, which is equal to 1 by 2 ip omega square, where ip can be written as what? M r square. By the theorem of parallel axis, we can write the value of ip as m r square for a body when it is rolling, right? Then next we have the linear velocity of different points in rolling. When the object is rolling, the velocity at different point of contact will be varying or it will be same. Let us see that. In case of a rolling, all the point of rigid body have same angular speed but different linear speed. The angular speed will be different. Why? Because the angle will be varying here, therefore the angular speed will be different, but the linear speed will be speed will be different, but the angular speed will be same here. The angular speed will be same. So here you can see in the figure that different points they have considered. Point A, B, C, and D are the 4 points. Then their velocities are shown in the following figure. See here, that is rolling on an inclined plane. So what is rolling on an inclined plane? When a body of mass m and the radius, it is having the radius r, which rolls down on an inclined plane. When it rolls down on an inclined plane from the height h, the angle of inclination is theta. The angle of inclination is theta. It loses potential energy. So when it is rolling down, it loses what? Potential energy here. However, it acquires both linear and angular speed, and hence it gains the kinetic energy of translation and that of rotation. Okay, so by the conservation of mechanical energy, mgh is equal to half mv square into bracket 1 plus k square divided by r square is the expression for mechanical energy. Next here we can see that is velocity at the lowest point. It is given by v is equal to under root of 2gh divided by 1 plus k square by r square. Then the acceleration in motion expression is what? It is v square is equal to u square plus 2s. So we can substitute the value of u as 0, that is the initial velocity as 0. Then the value of s can be written as h divided by sine theta. H divided by sine theta. Therefore, we can write v is equal to square root of 2gh divided by 1 plus k square by r square. Here we will get acceleration a is equal to g sine theta divided by 1 plus k square divided by r square. Like this is how we can write the expression. Then here we have the expression for time of descent. So time of descent means what? When the object is rolling down, that time we take it as time of descent. If it is going up, we take it as time of ascent. Then total time we can write it as total time of ascent plus time of descent. So time of descent from the equation can be written as here. We can substitute the initial velocity 0 and value of v and a from above expressions. It is given by time period t is equal to 1 upon sine theta square root of 2h divided by g into bracket 1 plus k square divided by r square. This is what t is equal to. We have v is proportional to. So what is v is proportional to? It is 1 divided by square root of 1 plus k square by r square, and a is proportional to 1 divided by 1 plus k square by r square. Similarly, t is proportional to what? Root of 1 plus k square by r square. So from this last expression, we need to remember the value of v, acceleration and time. It is how it is related to k, radius of gyration, and the value of r here. Okay, this is how we can write the expression. Right. So this is regarding the body when it is slipping, sliding and rolling. What is the expression in different conditions we have discussed. Right. Then next. So already we have discussed about angular momentum and the different relation for torque and angular momentum. So torque and angular momentum is given by what? That is rate of change of angular momentum is also called as what? Torque. That one thing we should remember. Okay. So here we will discuss about the equilibrium of a body. What do you mean by equilibrium of a body? That is to say that if the body is in equilibrium, it should satisfy two conditions here. So next point we are discussing here, that is equilibrium of a body. What do you mean by equilibrium of a body? Here the first thing what it should satisfy, that is a rigid body is said to be in translational equilibrium if it remains at rest or moving with a constant velocity. So when the bodies are moving with a constant velocity, or if it is at rest, then we can say that the bodies are in equilibrium condition. It is said to be the bodies are in equilibrium condition. Here we can prove this also. That can be written as so F1 plus F2 plus and so on up to Fn is given by dp divided by dt, that is rate of change of momentum. So here the F external is equal to, it is dp divided by dt, that is equal to d divided by dt into bracket m into v. Here what happens? M is constant, that we can take it out. Then as we have said the condition, the body should move with a constant velocity. So when we say that it is moving with a constant velocity, we can write dv by dt is equal to what? 0. So when we write it as dv by dt is equal to 0, this expression becomes 0. Therefore, the f external is nothing but what? 0 here, which means that When there is no external forces acting on a body, the body is moving with a constant velocity or it is at rest, which means that the body is in equilibrium condition. So this is the first condition, so that the body should be at equilibrium condition. Then let's see the second condition now. The second condition is what here, that is so second condition is a rigid body is said to be in rotational equilibrium if it does not rotate and rotates with a constant angular velocity. If the body rotates with constant angular velocity, then we can say that the body is in equilibrium condition. The first condition we explained based on the translational motion. The second one we are explaining based on the rotational motion here. We are explaining based on the rotational motion. Then next, toe external is given by here. This also we can prove that here if toe 1, toe 2, toe 3 are the external force or external torque which is acting on a body, then here we can write that is toe external is equal to toe 1 plus toe 2 plus toe 3 plus and so on. Okay, here we already know that toe external is can be defined as what? It can be defined as what? Rate of change of angular momentum. Okay, so when we say that the angular velocity is constant, angular momentum also we can take it as constant. So when angular velocity is, sorry, angular momentum is taken constant, the value becomes toe external is equal to 0, which is nothing but what? When there is no external torque is acting on a body, the body is moving with a constant angular velocity. So these are the two conditions for equilibrium of a body. Then next we have the principle of momentum. Sorry, principle of moment. Already we discussed about momentum. Now let us see for moment here. So principle of movement, how we can define it? That is, suppose if you consider a rod, just consider a rod PQ. So this is P, this is Q of negligible mass. Here this is supported with some system. Okay, means whole mass of this rod is pointed at this point. So you can balance this rod with the help of this point here, or you need to balance it in such a way that it should balance on this point now. Here from the center, this is at a distance of, means this is at a distance of D1 and this is at a distance of D2. Suppose if you take two objects which are hanged at P and Q, now here the weight at this point is taken as mg. So F1 is equal to, it is written as mg, and here the force F2. Means here when two bodies are suspended, here this tries to pull this object in this direction and this will tends to move along this direction. Therefore here what happens? Clockwise and anti-clockwise movement takes place. So from the center or from this support, the moment of force is given by, the moment of force is given by, it is F1 D1, and at this point it is given by F2 D2. It is given by F2 D2. Then what is the net force acting at the center? It is given by F1 D1 minus F2 D2, which is equal to 0. Therefore, we can write it as F1 D1 is equal to F2 D2. What is the meaning of this? That is, anti-clockwise moment of force must be equal to clockwise moment of force. Clockwise moment of force. So this is nothing but what? Principle of moments. Principle of moments. So what this principle of moments states that? It states that the anti-clockwise moment of force must be equal to the clockwise moment of force. Okay, so this is regarding the principle of moments. The next we have one more definition called as center of gravity. We have studied about center of mass. What do you mean by center of gravity here? Center of gravity is nothing but here it is defined as it is that point where the whole weight of the body were supposed to act. So it is that point where whole body weight is supposed to act. That point on a body or of the body is called as what? Center of gravity. That is called as center of gravity here, right? So already moment of inertia and moment this one radius of gyration, everything we have discussed, and the expression for moment of inertia for different bodies, it is varying. Suppose if you consider a thin rod, the moment of inertia will be one that is 1 by 12 m into L square. That is for what? Thin rod. So like this, the value will vary from different shape of the body. Okay. Suppose if you consider a circular ring, then its moment of inertia is given by I is equal to mr square if the line is passing through the center of the ring. If it is a diameter, then it is given by 1 by 2 mr square. If it is tangent to the ring, then the moment of inertia is given by 3 by 2 mr square. Like this, the moment of inertia value will vary from different shape of the, it will vary for different shape of the body, right? Then next, let us go for the multiple choice questions. The first question is, the distance between the carbon atom and the oxygen atom in a carbon monoxide molecule is 1.1 angstrom. It is 1.1 angstrom. Angstrom in the sense it is 10 raised to minus 10 meters. Given mass of the atom, carbon atom is given, it is 12 AMU, atomic mass unit. Then next, mass of oxygen atom is also given, it is 16 AMU. Calculate the position of the center of mass of the carbon monoxide molecule. So for carbon monoxide molecule, we need to calculate. The options are given, that is 6.3 angstrom from the carbon atom, 1 angstrom from the oxygen, that is 0.63 angstrom from the carbon, 0.12 angstrom from the oxygen. So we need to calculate the distance of carbon and oxygen in carbon monoxide. So carbon monoxide, the formula will be CO. Okay, the distance between them we need to calculate. Suppose if you consider the carbon is at the origin. Suppose if we consider the carbon is at the origin and oxygen atom is placed at the x-axis and oxygen atom is placed at the x-axis. So according to the question, here we can just show one rough figure, that is, suppose this you assume it as carbon and this I'll consider it as oxygen. So this I'll take it as x-axis and this one I'll take it as y-axis. Here the mass is m1 and here the mass is m2. So masses are given, that is 12 AMU and 16 AMU. So center of mass of the system of particles is given by, what is the formula? It is R is equal to m1r1 plus m2r2 plus and so on up to mnrn whole divided by, it is m1 plus m2 plus and so on up to mn. Right? So according to this, let us substitute, that is r1 is equal to 0 into I plus 0 into j and R2 is equal to 1.1 into I plus 0 into J. Therefore, R can be given as vector R is equal to M1 R1 plus M2 R2 divided by M1 plus M2 divided by M1 plus M2. So substitute, it is 16 into 1.1. Okay, divided by M1 plus M2. That is 12 plus 16 is nothing but what? 28. It is nothing but 28. Therefore, R is equal to, you will get it as, simplify the 16 into 1.1 divided by 28. You will get it as 0.63. You will get it as 0.63 here. So this 0.63 angstrom we will get from the carbon atom. 0.63 from the carbon atom. Right? This is how we can write. We can calculate the distance or the center of mass position for two different molecules. So not only this, we can use the same formula if any other molecules are given. So this formula is used when the diatomic molecules are there. The center between them can be calculated by using this formula. Next. Masses 8242 kg are placed at the corners of A, B, C, D. They are placed at the A, B, C, D respectively. It is a square of diagonal 80 centimeter. Its diagonal is given by 80 centimeter. The distance of the center of mass from A will be. The distance of center of mass from A will be. So according to the question, we will take the figure. It is a square. So consider a square. So if you consider a square here, so this is a square, we can take it as, and here we can name it as A, B, C, D are what? The four corners here. It is mentioned that, so the masses are given respectively. Therefore, at A it is 8 kg, then it is 2, then here it is 4, and here it is 2. Like this, the masses are placed. Okay. Then so if here we can consider that let A be the side. Let A be the side of a diagonal. So suppose if you consider this as x-axis, means whatever this AB is there, this position as x-axis and this position as y-axis. The coordinates at A, it is like a 0, therefore the coordinates will be 0, 0. And at B, the coordinates will be x value is A, y value is 0. At C, the coordinates will be AA, and at D, the coordinates will be 0, comma A. It will be 0, comma A here. So like this, we can take the coordinates. Now we can do the simplification. That is, D is equal to, the distance is equal to, it becomes A divided by root 2. That is nothing but it is given as it is 80 centimeter, which implies A is equal to what you can write? A is equal to, you can write it as it is 80. Sorry, this is A into root 2. It is A into root 2. That is 80 centimeter. Therefore, A is equal to 80 divided by root 2. So 80 divided by root 2 can be written as, this root 2 can be written as root 2 into root 2. So if you do the simplification here, this 80 can be written as 40 into 2. So 2 will get cancelled. Therefore, we can write it as 40 into root 2. The value of D will be 40 into root 2. The masses values are given. Therefore, the unit vectors can be written as, that is, R1 is equal to, it becomes 0 I cap plus 0 j cap. Similarly, R2 can be written as, already we have written the coordinates. It can be written as A I cap plus 0 j cap. Then R3 can be written as A I cap plus A j cap. Then R4 can be written as 0 I cap plus A j cap. So now we can use the formula. That formula is what? R is equal to, it is M1 R1 plus M2 R2 plus N, so on. They have given 4 particles, therefore we can take M4 R4 divided by M1 plus M2 plus M3 plus M4. So now we can substitute the values and we can simplify it as, here it becomes 15 root 2 into I plus 15 root 2 into J. So the coordinates of center of mass is given by, the coordinates of center of mass is given by, it is equal to 15 root 2 comma 15 root 2, 15 root 2 comma 15 root 2. Therefore, we can calculate the distance between the two center of mass from A as, it is equal to, distance is equal to, so we can use A square plus B square formula, that is X square plus Y square formula, that is given by 15 root 2 whole square plus 15 root 2 whole square. So if we simplify this, we will get it as under root of 900. So root of 900 is nothing but what? It is 30 centimeter. It is 30 centimeter. That is, option B is the right option here. Option B is the right option. Next. Next question is, the angular velocity of second hand of a watch will be. So we need to calculate the angular velocity of second hand. That is given by, so very simple this is. We know that angular velocity omega is equal to, it is theta divided by t. So theta is equal to, for second hand, complete revolution is given by, so for second hand, complete revolution is 2 pi divided by 60, which is equal to, it becomes pi divided by 30 radian per second, 30 radian per second, right? So that is option B is the right option here. Option B is the right option. Next question. The wheel of a car is rotating at the rate of 1200 revolutions per minute. Okay, revolutions per minute is given as 1200. That is angular velocity value. Next, on pressing the accelerator for 10 seconds, it starts rotating at 4500 revolutions per minute. So when you accelerate it for 10 seconds, it starts rotating at 4500 revolutions per minute. The angular acceleration of the wheel is given by. So they have given the value of angular acceleration is nothing but what? We know that angular acceleration is nothing but what? Rate of change of angular velocity. That is omega 2 minus omega 1 divided by t. Here we know that omega 1 is equal to, it is given as 1200 revolutions per second, that is 1200 by 60 revolution per second. And omega 2 is equal to, it is 4500 revolution per second. Therefore, it is 4500 divided by 60. Therefore, substitute the value now. That is alpha is equal to, it becomes 75 minus 20 divided by 10, because they have given in turn 10 seconds. So this 600 will get cancelled. 6 ones are 6 twos are zeros, that is 20. And here also you can simplify, you will get it as 75 minus 20 in 10 seconds. So just simplify this one. 75 minus 20 is how much? It is 55. 55 divided by 10. So answer is nothing but it is 5.5 revolution per second. It is 5.5 revolution per second. So here you can see that the options are, actually these options are given in terms of radian per second square. It is given in terms of radian per second square. We got the answer in terms of revolution per second. Therefore, we can convert this revolution per second into degree by using the conversion factor 5.5 into 360. So 5.5 into 360 is nothing but 1980 degree per second square. 1980 degree per second square. That is option D is the right option here. Option D is the right option. Okay. Next question. Angular displacement of a flywheel varies with time as theta is equal to a into t plus bt square plus ct cube. Then angular acceleration is given by. So we need to calculate the angular acceleration again. They have given the equation as at plus bt square plus ct cube. Okay. So we have angular velocity is equal to d theta divided by dt, which is equal to d by dt into bracket at plus bt square plus ct cube. So differentiate this equation with respect to time. It becomes a plus 2bt plus 3t square. 3t square. So this is what angular velocity. Angular acceleration is given by what? Alpha is equal to d omega divided by dt. That is equal to, so second time differentiation for the same equation, it becomes 2 into b plus 3c into t. 2b plus, sorry, here already 3 is there, into 2, that is 6. It becomes 6 ct. It becomes 6 ct. So if you see the options, they have given it as a plus 2bt minus 3ct square. Second option 2b minus 60. Third option a plus 2b minus 60. Fourth option is 2b minus plus 6ct square. Here the correct option is option D. Option D is the right option. Next question. A wheel is at rest. A wheel is at rest. Its angular velocity increases uniformly and becomes 60 radian per second after 5 seconds. The total angular displacement is, so we need to calculate the total angular displacement. Already we know the formula. Here they have given. First, angular acceleration is equal to, it is omega 2 minus omega 1 divided by t. That is equal to 60 minus 0 divided by 5. That is equal to 60 by 5 is how much? It is 12 radian per second square. 12 radian per second square. So we have equation theta is equal to omega 1 into t plus half alpha t square. Omega 1 into t plus half alpha t square. This is equal to, here the wheel is at rest. Therefore, this omega 1 value becomes 0. Therefore, omega 1 into t is 0 plus 1 by 2 alpha value is 12 into t square is how much? It is 5 whole square. So 2 ones are 2 sixes are. Then 5 square is 25. 25 into 6. So 25 into 6, that is 150 radian. That is 150 radian. This is what the displacement of the body. The displacement of the body is given by 150. Option B is the right option here. Next question. 5 particles of mass 2 kg are attached to the rim of a circular disc of radius 0.1 meter. The radius disc is given. Its mass is 2 kg and moment of inertia of the system about the axis passing through the center of the disc and perpendicular to its plane is given by. Here the moment of inertia we need to find out. They have given mass and radius of the disc. As it is a circular disc, we have the moment of inertia formula for circular disc as it is phi r into r square into m. That is, moment of inertia is given by I is equal to phi m r square. That is equal to phi into m value is 2 into r value is 0.1 whole square. Right. So 5 into 2 is 10. 10 into 0.1 into 0.1. So the answer is how much? 0.1 kg meter per kg meter square. Kg meter square. That is option B is the right option. Here option B is the right option. Simple question, but we need to know the moment of inertia of circular disc. Next question. A circular disc of X of radius r is made from an iron plate. Okay, so you have a circular disc which is made from the iron plate of thickness t, and another disc y of radius 4r is made from an iron plate of thickness t by 4. Then the relation between the moment of inertia for this disk X and for disk Y. So as it is a circular disk, here what they have given, the thickness value is given as T and T by 4 and radius is given as R and 4 by 4R. Okay. Here, the moment of inertia of a disk perpendicular to plane. We need to consider perpendicular to plane now. So when we are considering for perpendicular to plane, we have the formula that is moment of inertia I is equal to 1 by 2 m into r square is equal to 1 by 2 pi r square t into rho into r square. So this is equal to, it is 1 by 2 pi r square into r square. It becomes r raised to 4 t into rho. Right. So as we know that mass is equal to, or density is equal to mass per unit volume. Therefore, this equation can also be written as pi r square t into rho. Pi r square t into rho, where rho is the density, t is the thickness of the body. Okay, so they have asked you the relation between Ix and Iy. Let us take the relation between Ix and Iy. I can write it as it is Iy divided by Ix is equal to. So Iy can be written as Ty, this is by Tx into Ry divided by R into X. It is whole to the power of 4 as density remains constant. The Iy by Ix is equal to, it is 1 by 4 because they have specified that Ty value is T by 4 and Tx value is T. So if you simplify, you will get it as 1 by 4 into bracket Ry by Rx, that is 4 to the power of 4. So 4 to the power of 4, this becomes 4 cube. That is nothing but 64. That is nothing but 64 here. Therefore, we can write Iy is equal to 64 into Ix. Iy is equal to 64 into Ix. That is option A is the right option here. Next question. 3 point masses, each of mass m, are placed at the corner of an equilateral triangle offside A. Then the moment of inertia of the system about an axis which is passing along one side of the triangle is given by. So here again we need to calculate the moment of inertia. They have given that it is a triangle at the corner, means the side of the equilateral triangle is given as A. See here, as it is an equilateral triangle, we will consider the each side as A and A. So mass at A is means this we can name it as A, B, C. So mass at A is given as m, B is also m, C is also m. Okay. Each mass is given as m and the sides are given as A. The moment of inertia we need to calculate. The moment of inertia of the system about AB side. So about AB side, if I take here, it is given by I is equal to IA plus IB plus IC, which is equal to, so which is equal to, it becomes 0 plus mx square. The 0 plus mx square. Why? Because here the midpoint we can take it at of the triangle. Here we can show the midpoint of this triangle. Therefore, due to IA it is 0, IB also it is 0, and due to IC it is given by mx square. So as we know the value of x here, we can write it as I is equal to m into bracket x square it is, that is nothing but a into root 3 divided by 2 whole square. Therefore, it becomes 3 divided by 4 m into a square. 3 by 4 m a square. That is option C is the right option here. Option C is the right option. And the next question is, the resultant of the system in the figure is a force of 8 Newton parallel to the force through R. The value of PR equals to. So here you can see that the figure is given, the rod PQ is there, then its center is denoted as R. At one side, the force applied is 5 Newton, and at the other side, the force applied is 3 Newton. So we need to calculate the value of PR here by taking the moment of force about the point P, that is R. It is given by, according to the principle of movement just now we discussed, phi into PR is equal to, it is 3 into PQ. They have asked you to calculate PR is equal to, therefore PR is equal to 3 by 5 into PQ. 3 by 5 into PQ, that is option, sorry, it is RQ. It is not PQ, it is RQ here. Here also it is RQ, here also it is RQ. So 3 by 5 RQ, that is our option C is the right option. Next. A ring of radius 0.5 meter and mass 10 kg rotating about. It is rotating about its diameter with an angular velocity of 20 radian per second. The kinetic energy will be, so we need to calculate the kinetic energy. We need to use the rotational kinetic energy formula that is given by 1 by 2 that is I omega square. I is moment of inertia, omega square is equal to 1 by 2 into bracket 1 by 2 m r square into omega square. So this 1 by 2 I have written as it is. I is moment of inertia, and that is given by 1 by 2 mr square into omega square. So this is equal to 1 by 2 into bracket. This 1 by 2 I'll write as it is. Mass is given as 10 kg into R value is given as 0.5, as it is R square. It can be written as 0.5 whole square, and it is omega square value. Omega value is 20 its whole square. So this is 2 ones are 2 5s are. Everything is in multiplication. So directly we can simplify and we can calculate the value of kinetic energy for the rotational motion. The kinetic energy is given by 250 joules. The kinetic energy value is 250 joules. That is option D is the right option here. The kinetic energy is given by half I omega square. Just substitute the moment of inertia value, means the formula, then do the substitution. Next question. An automobile engine develops 100 kilowatt when rotating at a speed of 1800 revolution per minute. What does the torque given by this motion? Okay, so here the power is given, the power value and the speed value is given. So we know the power and speed relation in case of rotational motion. The expression is given by power is equal to, it is tau into omega. It is tau into omega. So it develops a power of, the power value is given as 100 kilowatt. So I can write it as 100 into 10 to the power of 3 divided by, so omega. Omega is how much? 180, sorry, 1800 revolution per minute. This I can write it as 2 pi into 1800 divided by 60. That is equal to what? 2 is equal to, that is equal to 2. So here 2 is equal to, we can simplify that, 100 into 10 to the power of 3 into 60 divided by 2 into pi into 1800. So just simplify this. After simplifying, we will get it as 531 Newton meter. The torque value it is. So the torque is expressed in terms of Newton meter. 531 Newton meter is the answer. Option C is the right option here. Let's see the last question. Okay, so two disk of moment of inertia I1 and I2 and angular speed omega 1 and omega 2. So you have two disk whose angular speed is omega 1 and omega 2 and its moment of inertia is I1 and I2. They are rotating along the collinear axis through their center of mass and perpendicular to their plane. If the two are made to rotate together along the same axis of rotation, the kinetic energy of the system will be. So we need to calculate the kinetic energy of the system by the law of conservation of momentum, that is angular momentum. Here we can write it as, that is given by Li is equal to Lf, that is initial angular momentum is equal to final angular momentum, right? So let us write the equation. This is I1 omega 1 plus I2 omega 2 is equal to I1 plus I2 into omega. The angular velocity is given by omega is equal to. So keep this omega here, transfer the term. It becomes I1 omega 1 into, sorry, plus I2 omega 2 divided by I1 plus I2. This is what angular velocity. They have asked you to calculate what? The kinetic energy of the particle. So kinetic energy is equal to, the expression is what? It is half I omega square. As the two bodies they have given, it becomes I1 plus I2 into omega square, which is equal to 1 by 2. This I1 plus I2 I'll keep as it is. I1 plus I2 I'll keep as it is. Omega value, just now we calculated, it is I1 omega 1 plus I2 omega 2 divided by I1 plus I2, this entire square. So it is whole square. Therefore, what happens? I1 plus I1 plus I2 will get cancelled. Therefore, you are left with the kinetic energy is equal to, see in the numerator we have I1 omega 1 plus I2 omega 2 to the power of whole square divided by 2 into bracket I1 plus I2. 2 into bracket I1 plus I2. That is option C is the right option here. Option C is the, sorry, option B is the right option. Correct. That is I1 plus I1 omega 1 plus I2 omega 2 whole square divided by 2 into bracket I1 plus I2. Right? Option B is the right option. Option D is given as none of this. So, but here we are getting option B. Right? So these are the multiple choice questions based on system of particles and rotational motions. In the next class, let us continue with few more questions. Thank you.